Hello, my name is Emily Duncan, and today we will be finding the exact value of each of the remaining trigonomic functions of theta when the cosine of theta is -3/5 and theta is located in quadrant 3. First, let's find the sine of theta. In order to find the sine of theta, we must remember that the definition of cosine is adjacent over hypotenuse. Additionally, remember that the definition of sine is opposite over hypotenuse. If we can remember the Pythagorean theorem, we can figure that adjacent squared plus opposite squared will give us the hypotenuse squared. So, if we set this up in a Pythagorean formula, we can figure that -3 squared, the adjacent leg, plus y squared, the opposite leg, equals 5 squared, the hypotenuse. And when we figure that all out, we find that y squared equals 16 and y equals 4. So our missing leg is 4. And because sine is the opposite over the hypotenuse, sine is 4 over 5. And because it is located in quadrant 3, -4 over 5. Next, let's find the tangent of theta. The tangent is simply sine divided by cosine. So -4 over 5, which we just determined was the sine of theta, times the reciprocal of cosine, and the reciprocal of -3/5 is 5 over -3. That gives us 4/3, which is the tangent of theta. Now, we will move on and find the cotangent of theta. The cotangent of theta is simply the reciprocal of the tangent of theta. So the tangent of theta is 4/3, and the reciprocal of that is 3 over 4. We will do the same thing for finding the secant and cosecant, as the secant is simply the reciprocal of cosine, and the reciprocal of -3 over 5 is -5 over 3. So our secant theta is -5 over 3. And the cosecant of theta is the reciprocal of the sine of theta, and because the sine of theta we determined was -4 over 5, the cosecant of theta is -5 over 4. And now we have found the remaining trigonomic functions of theta.